Okay, so we're going to have an oxidation reaction. We're going to have a reduction reaction here. Okay, so we got to figure out which one is which. As you find what looks the most alike, they go together, so have chromium here and chromium here as well. Okay, then you've got peroxide. Okay, so here's our two half reactions. So that's our first step. Okay, so I gave you a list of kind of all the steps on Wednesday, so hopefully you've got that out with you, or you've been looking at that, or may know them already. Okay, so the next step is we've got to mass balance. So just like usual, or just like we've been doing, okay, except for we might run into an issue where we don't have hydrogens or oxygens. But other than that, we mass balance, so we have to have the same number of atoms on the left-hand side as we do on the right-hand side. Okay, so if we look here, we've got chromium on each side, so we move on to our oxygens or our hydrogens. Okay, so it looks like we've got 4 oxygens, okay, and then we've got 4 here. Okay, but over here we have 4 hydrogens. Okay, so if we have hydrogen on one side of the equation and we have 0 on the other side, what do we have to add over here? Okay, so it's actually called a proton. It's not, as it's not neutral hydrogen, it's an H+. Okay, so be sure that you, okay, so how many are we going to have to add? Okay. Very good. Okay, so now we are mass balanced, but the difference with these equations is now we have to be charge balanced. So this is where we add electrons. Okay, remember, redox reactions are the loss and the gain of electrons. Okay, that's what's going on here. Okay, so we want to add up the total charge on each side. Okay, so you can imagine that this arrow here is an equal sign. Okay, so it's got to equal each other. Okay, so on our left-hand side, we have a negative, that's understood 1. Okay, we have no coefficient here, or we do, it's a 1, understood 1. So we have a -1 charge total on the left side. Okay, so over here, if we add up, what would be our total charge on this side? Okay, so we have +4 minus 2. So we have a 2. So you can put this if you want to, just +2. Over here, we have a -1. Okay, so these have to be equal. So we're going to add electrons to the more positive side. Okay, anytime you have to add these numbers of protons here, usually means probably this side is going to be the more positive side. Okay, so how many electrons will we have to add to the product side? Okay, -1. Okay, so we're going to have to add 3. Oh, I'm running out of room here. Okay, so that's like -3. That's a crazy looking 3 there, but okay. So now we have -1 equals -1. We have +2 minus 3 equals -1. Okay, does everybody see how adding electrons here is you're adding negative charge? Okay, so you're subtracting these 3 electrons. Think of it that way. Okay. All right, now we have to look at, so if you look back at this, you can check it if you would like, but you should have the same number of atoms, the same charge on both sides. Okay, now let's label this reaction as oxidation or reduction. Okay. So we have electrons on the product side. Okay, that means that chromium oxide had to lose this many electrons. So lose electrons equals oxidation, right? Leo and Ger. Okay. Uh-oh. Sorry. Hope everybody got that. Okay. It's actually that's confusing. Actually, I don't test on it. It's actually the reducing agent, but it's being oxidized. It's confusing, so don't worry about that. Okay. Okay, we'll do the next one over here. Okay, so we have so go ahead and see if you can balance while I'm getting this written back out. The next half reaction. We've got 2 hydrogens and 2 oxygens. So we've got hydrogen peroxide on the left. Okay, so what can we do to our product side? Okay, we can just add a 2, which means now we have 2 oxygens and 2 hydrogens. So we're balanced. We don't have to add water or add a proton. Okay, so now we have to charge balance. Okay, we have neutral over here. We have no negative or positive ion on the left. Okay, and so what's our charge on the right-hand side? -2. So we have basically we have 0, neutral, and we have -2. Okay, and the only way that we are balancing these equations is by adding electrons. So that's negative charge. So we have to add that to the more positive side. Okay, so our more positive side is our neutral side. Okay, and so if we add 2 electrons here, now we are charge balanced. No. Okay, so we have our 2 half reactions. So basically what's left is we have to put them together. Okay, so we've broken them into 2 parts. Now they're mass and charge balanced. So if we do everything else from this point correctly, then at the end we should get a mass and charge balanced equation. Okay, so does anybody remember what we have to do now? What's our next step? Electrons, exactly. So you're not going to have electrons left over in your final equation because the electrons have to cancel each other. Okay, so we have 3 electrons in our first half reaction. Okay, and this is our reduction, right? Because we've gained electrons. They're on the reactant side. Okay. Okay, so now we have to multiply through both of the equations so that our electrons will be equal. Okay, so we're going to have to multiply everything through by 2 here, and multiply everything through, do it over here, by 3. Okay, on this step, it's common for students to make the mistake of trying to multiply this number times the charge or add it to the subscripts or whatever. That number only multiplies and will only change the coefficient out front. Okay, nothing else will change. Okay, so if we bring this down, so we've got 2 should have told me I got a mistake up here. I'm wondering what in the world I'm doing. There we go. I multiply everything through by 2, and it changes my coefficients out front. So we get 8 H plus, 6 electrons. And then if we multiply by 3, we get 6 electrons, which is what we're aiming for these 2 to cancel. And we get 3 hydrogen peroxide atoms, or molecules, and 6 hydroxide. Okay, so now we simplify. So we look for common terms on either side of the equation. Okay, so we know that our electrons have to cancel out. Okay. Does anybody else see anything that could cancel? Looks like the electrons are the only things that are identical there. Okay, has everybody got this? Because I'm about to go up to the top there. Okay, so now we're just going to rewrite it. So rewrite your equation, and you're going to bring all of your reactants together and all of your products. I like to match up my arrows because sometimes equations will be, one will be really short and one will be really long. And if you move it over, you might accidentally put reactants on the product side or get them mixed up. So be sure you try to line them up that way. So add everything together. Okay, so if this was acidic conditions, then this is where we would stop. Okay, so we've completed all of the, I think it's 7 steps or so there. Okay, so if you look at your handouts, hopefully everybody's got it with them. I don't know where mine is, but if you look after those 7 steps for the acidic condition, okay, now look at the steps for basic solution. Okay, so remember that hydroxide, so OH minus means basic conditions, and H plus means acidic conditions. Okay, all right. So if you look at your steps, okay, so I encourage you guys to make notes, add things to this, so that when you're doing these on your own, you can go back and look at it. Okay, it says perform steps 1 through 7 above. Okay, so that's what we just did. We just simplified, and we got our answer there. And then it says for every H plus ion in the equation, add the same number of hydroxide ions to both sides. Okay? You have to add to both. If you don't, then you've just unmass balanced your equation. Okay, so you have to do the same thing to both sides. Okay, so let's do what that says. So if we find our H plus, okay, this is what we're replacing with hydroxide because we're in basic conditions. Okay, so if we read that rule, what do you think we're going to do? Okay, do what? Okay. Yep, so we're going to add 8 hydroxides. But then what do we have to do? Add 8 to the other side. Okay, so the last part, this one sometimes gets students, but you're going to add your H plus ions and your hydroxide ions together to form water. Okay, and then you simplify if you need to again. So that's just canceling out like terms. Okay, so if we look here, we have 8 H plus and we have 8 hydroxides. Okay, so if we look at the charge, so if we were to add these together, we have a positive and we have a negative charge. So those would cancel. So we would end up with a neutral molecule. Okay, so if H plus and hydroxide combine, they form water. Okay, we have 2 hydrogens and an oxygen. Okay, so in reality, in solution, these ions react together to form water. Okay, so these 8 hydroxide ions and protons, we pretty much will cancel these out, and we're going to form 8 molecules of water. Everybody see that? Okay, so now these are no longer, see our H plus is now gone because we're in basic conditions. Okay. Okay, we still have our hydroxide over here. Okay, everything should still be mass and charge balanced. Okay, and I'm trying to see, I don't think there's anything else that, oh, there is. Okay, it says add these ions together to form water, which is what we just did, and then simplify. Okay, you may or may not have to continue to simplify. It just depends on the equation. Okay, so do you guys see anything else that we could simplify or cancel out? Anybody? We have 2 like terms on the same side, the same molecules. This might help if it looked a little neater here. So we combine these together to make water. So this is gone. Okay. Any ideas now what we might could do to simplify a little bit further? Yes. To make water? What do you mean? Well, you have a proton and you have hydroxide. So when they combine, they form water because you have 2 hydrogens and 1 oxygen. So they combine to form water. Okay, so if you have 8, okay, you just added 8 hydroxide, right? So that 8 plus the 8 of the protons, because you had to add as many protons as you had, combined together to form water. Okay, but this is left alone. Okay, the last step that we can do is see how we have hydroxide on both sides. Okay, so what we can do is simplify. So we can this out, 6 into 8, and we have 2 left over. Okay, so the final okay, we balance it. Looks like you guys, from what I could tell, did pretty good with the first 7 steps. Okay, the last few, take practice. You've got lots of practice. I even give you some examples or some problems to go to in your book. So I encourage you to work all those, especially if you're having trouble or having issues kind of putting it all together. Okay, the last thing you do for a basic condition is you add hydroxide to both sides. You combine the H plus and the hydroxide to form water, and then you simplify. Okay, if there are like terms on each side. Okay, I think I gave you 48 through 61 in your textbook. Even, do all of them if you'd like, but those are all good examples, I believe, so you can work those on top of the worksheets as well. Okay, any questions for this? Yes. Yeah, it's almost, you're simplifying, it's almost like you're just dividing the 6 into the 8, and you have 2 left over. So subtract, yeah, that's fine. You subtract them. Yeah, 1 should cancel out completely. Okay. All right, I'm going to give you guys one to work. I'm going to talk about it real quick. Get it up here. So be sure you copy it exactly, because if you forget the charge or you forget a subscript or anything like that, that's going to throw off your whole answer. Okay, there are 2 ways that you can be asked this to balance these equations. So you can either just be told it's under acidic conditions or it's under basic conditions. Okay, or your book does this a lot, it is written into the equation. Okay, so this for some reason really confuses students, so listen up for a second before you start this. Okay, I'm not going to ask you to balance equations more than you will have 1 compound or reactant and you will have 1 product, and that will be your half reaction. I'm not going to have you have more than 2 half reactions, okay? So here we've got 3 terms on the left and we've got 3 on the right. Okay, so if you try to break that down, that would be confusing, right? Because we've only been looking at 2 half reactions. Okay, all that is going on here is this here. Goes with this water there, and all that's telling you is that it's under acidic conditions. Okay, that H plus there is telling you acidic conditions. So what I would do if that confuses you or whatever, I would just mark through it, because you're going to be placing in H plus as that's part of your rules and your steps to put that in there. So don't try to balance it there, don't try to go back to it, it will work out itself as you are doing the steps. Okay, all that's telling you is it's acidic conditions. Okay, so you can mark those out, and now you can go from here. So break down into your half reactions and then balance. Okay, so this will just be the first 7 steps here. Okay, and please ask questions. I'll come around and help if you have them. Yeah, sometimes it'll have the water molecule with it, sometimes it won't, but just mark them out, don't look at them, just balance it just like you've been doing. So you just take those 2, and then you just take those 2. Yep. You're talking about there? Okay. This, when I just said this and this, are just telling you that it's in acidic conditions. Yeah, you don't look at these at all. That's just saying, okay, this is in acidic conditions. Now I just break it back. Does that look like a 3? It does. Sorry, hang on. Sorry guys, that's not a 3. It looks like a 3. Okay. Okay. So yeah, you just balance this and this. Don't worry about this. This will come back into the equation as you go. Yes. Yes, that's where. So go ahead and just break it down like he's done. Break down your 2 equations first. Okay, and then yes. So if you look at your 7 steps here, it says mass balance half reactions by adding appropriate coefficients to balance hydrogen and oxygen. We add hydrogen to balance hydrogen, or waters to balance oxygen. Okay, so you're going to have to add 4 waters to this side. Okay, and then once you do that, you just added hydrogen, so you got to add hydrogen to the other side, H+. Mm-hmm. Okay, you can't just add oxygen because that's not a stable molecule. You have to add water. Okay, so I don't know if you were here on Wednesday, but we have a list of steps. Okay, so if you need oxygen, you have to add water to the other side. Yep. Hang on just a second. I saw Taylor's hand, I think. Does you have a question? Mm-hmm. Okay, that's your step right here. Okay, so if to balance hydrogen and oxygen, we can add H+ to balance hydrogen, or water to balance oxygen. Okay, so that means that if you need 4 oxygens, you have to add 4 water molecules over here. Okay, this is gonna come back into your equation, but you don't need to worry about it at this point. It's gonna come back, and you're gonna end up with water in your equation, but you're not gonna. It's gonna balance itself out as you do these steps. That makes sense. Okay, this right here is just telling you that this is acidic conditions. And then from here, you're about to add water, so you're about to add plus 4 water molecules. So as you do these steps, when you finish up step 7, your equation is going to be balanced, and it's going to have water in it, but you don't have to worry about it here trying to balance it early on. It's going to add in, because that's what the steps do. They add in water, and they add in the appropriate stuff to it. So now you had water, but now you added 8 hydrogens. So now you got to add 8 H+ to that side. Then charge balance. No, you don't go back there. Don't go back there. Just keep going. Don't try to. Did you have a question?
Yeah, I was wondering if I was taking the right steps here. I mean, am I heading in the right direction here by adding 3 Mn electrons here? So it's got 1 electron here. This was positive.
Okay. First thing you gotta do is break them into 2 half reactions. So break down your MnO4- yields Mn2+. Okay, Br- yields bromine 2. Okay, do that first. Okay, now mass and charge balance. Okay.
So I add bromine on this.
Well, no, you're not going to be adding bromines. You can't do that. See, that's Br2. So to balance, remember, just to mass balance, you have 2 over here, so you put a 2 right there as a coefficient.
Okay.
The only thing you can add that's not there is water and H+. That's it. Okay. Okay. Look back at step. Give your steps. Okay. Right here it says if you need hydrogen or you need oxygen, then you add H+ or you add water. Okay. Oxygen's not a stable molecule. You have to add water, 4 water molecules to this side. Yeah.
Okay.
Look at your steps, guys. Be sure you're Oh yeah, I think I skipped over that. I'm sorry. Yes, there you go. Okay, the only thing that you forgot, so when you add water, then you automatically just added hydrogen. So now you got to add 8 H plus to this side. Okay, so add 8 H plus. Okay, now your mass balance. So now you got to get charge balanced. Let me see.
So I've got a positive 2 charge and a negative 1 charge.
Okay, well.
Sorry.
Okay, that's okay. You just added 8 positive charge there.
Okay.
Yep. So you have a 7 plus 7 charge over here, and a plus 2 over here. So you're going to add 5 electrons to this side.
So the plus 7 came from my
8 minus 1.
Okay.
Mm-hmm. And so you're going to need 5 electrons.
Okay, and I'm going to add those.
Over here, because you add electrons to
Because
the
they're
more
negative.
positive side, yeah, because it's going to be like subtracting those electrons.
Okay, so then my charge would be balanced with this one.
Yeah, you just charged and mass balanced that one. Yep.
This one there.
Okay, is that a 2?
Yep.
Okay. Okay, and then you just had 1. Okay. Okay, you forgot your, see right here you have a negative? So you forgot your negative there. So you have a negative 2 charge. And so you're going to have to add 2 electrons. I'm not sure, yeah, over here. Yeah, you added to the wrong, I don't know where that came from, but that's your negative side, and
Yeah,
this is your,
if I added 1 over here, but it would make that a 2 negative.
yeah, you're actually subtracting whenever you add those electrons. So you add them to the more positive side. Yeah. Okay. Close. Somewhere you lost your H plus. I don't know what happened. Probably would have. I'd have to sit here for a little while. You should have had some H plus in your answer.
On this side?
I know what you did. Yeah.
So I had to add the H
So,
on this side?
so look, as soon as you add water, it's automatic. You got to add hydrogen to the other side because you just added. So that's what happened. That's probably all you did. It's close, but you're not. I think these are 8H plus. It's protons, so that would make this 8 minus 1. So your charge would be 7 over here. So I think that's all you did. Yeah, because you end up with H plus, but you should have 16 of those. Yeah.
I knew that didn't seem right. I was like, I need water, but
Yeah, as soon as you add water, you got to go to the other side and add hydrogen. Yep.
For every proton you add, you have to add something else.
That's only in basic conditions. So that's what we did earlier. This is acidic, so after the 7 steps, you're done.
Okay.
Okay. Okay, did everybody at least get this far? Breaking your half reactions? Breaking it down? I hope. Okay. All right, listen up. Let's go over it. Okay, we're in acidic conditions. I think people are still trying to go back and plug in and whatever. This H plus and this water, just say it's acidic conditions instead of me telling you it's acidic conditions. That's the way they represent it a lot of times in your book. Just cancel them out. Don't look at them. Don't come back to them. You're going to put those in because you follow the rules. So you're going to place those in as you go, so it takes care of itself through the rules that you have.
So we don't have to do it after the
No. You're balancing those. That's what's happening while you're going through those 7 steps. That's what you're doing there. Okay. So we have manganese 1 on each side, so we're good there. Okay. Then we run into an issue here where we have 4 oxygens and none on the other side. Okay. So if you look at your, I can't find the front of my thing, but whatever step it is. Step 3, okay, it says to balance hydrogen and oxygen, we add H plus to balance hydrogen and water to balance oxygen. You can't just balance or put oxygen O, okay, because that's not stable compound. You can't just add it in like that. Okay, so if we need 4 oxygens, then we're going to have to add 4. Okay, as soon as you add water, if the situation is where you have to add water, you automatically just added hydrogens that you don't have on the other side. Okay, so you're going to have to. So those go hand in hand pretty much. So make notes as when you're going through these steps that if you add water, you're going to have to add H plus to the other side. Okay, so we just added 8 hydrogens that we do not have over here. Okay, if you don't add the hydrogens, then you're not mass balanced. Okay, so we're going to add 8. Okay, and remember it's always H plus. Okay, not just a hydrogen. Okay, so now we're mass balanced. We have to be charge balanced. Okay, more than likely, or probably 99.9% of the time, the side that you had to add this, 8 protons or how many ever, that's probably your more positive side because you just added a whole bunch of H plus to that side. Okay, so if we look at our total charge over here, okay, what would our total charge be on the product side? Just 2. Okay, water's neutral there. Okay, so we have a +2. If you want to write it out, you can, or you don't have to. It doesn't matter. Okay, and on the reactant side, what's our total charge there? Okay, so we've got 8 times +1 minus 1 gives us 7. Okay, so we have a +7. Okay, now we have to add electrons to the more positive side. Okay, so this is our more positive side. Okay, so we want these to equal each other, so we need it to equal 2. Okay, +2. Okay, so how many electrons will that take? Very good. Okay, is this the oxidation or the reduction reaction? It is the reduction. Okay, this one's a little bit easier here. So we've got 1 bromine atom, 2 on the right, so we balance just like we would any other time back in Unit 2, I guess it was. So we add a 2 for a coefficient. Okay, we're mass balanced already, so now we have to be charge balanced. Okay, so we have a -2 charge on this side, and then we are neutral over here. Okay, so if we're neutral, that's our more positive side, technically. Okay, so how many electrons need to be over here? 2. Okay. Okay, and we have an oxidation. If you end up with 2 oxidations or 2 reductions, that you have done something wrong. You've added the electrons to the wrong side. Okay, so somewhere something's gone wrong. You should have an oxidation and a reduction for both of these. Okay, the next step, I forget what step it is, 5 maybe, I think on your sheet. Okay, the next step is that we have to have our electrons cancel. Okay, so we should not have electrons in the final answer, our final equation. Okay, so we've got 5 and 2. Okay, so what are we going to do? Okay, so we're going to multiply this all by 2 and this by 5. Okay. So I'm going to do this first one real quick. So we get Sorry, I'm looking at the final answer and writing this up here. Hang on. I put all my steps together. There we go. Okay, so we've got 2. I have to go to the board. This is okay, 2, 16, 10, 8. Okay. All right, so from this point, we simplify. Okay, and we're just doing this first 7 steps since we're in acidic conditions. Okay, so the whole point of multiplying through is so that our electrons will cancel. So we made our electrons for both to be 10. So those cancel. Okay, is there anything else that we could simplify? I don't see anything else. Do you guys? Okay, so then we just take all of our reactants. Okay, so you may want to have them lined up better than I have here. Okay, everything on the left side of the arrows, and then take everything on the right for the products. It doesn't matter what order you put everything in, as long as you have the reactants on the right side and the products on the right side. Everybody got this? Need a second? Okay. Everybody got it now? Okay, so from this point, you guys need to be sure you're doing the practice. I'm going to pull this up real quick so that you all Okay, here's the handout if you weren't here on Wednesday. Okay, homework 1 looks like so. Okay, it's got titration problems. Remember, you've got to be, the first thing we went over was titrations. Okay, and then it's got 4 of the redox. Okay, notice here, some places I tell you it's acidic, other places you have the proton there to tell you that. Okay. Yeah, if it's hydroxide, then it would be basic. Yeah. Okay, don't be putting up yet. We're moving on a little bit here. Okay, this is what you need to have for a few minutes today, and then on Wednesday, I would suggest that no one miss that class because it's going to be jam-packed on Wednesday. That's the last day of material, okay, for you guys. And if we don't finish it, then we'll have to finish it on review day. So we need to get it in. I was hoping we'd get further than we are today. Okay, you need to be sure you look over this. This is a handout for you that gives you highlight points to the chapter. I mean, this is something I went through and did for you guys so that it would give you a guideline and kind of get you started. It's a great thing to read through before you ever even open the chapter, just to look, read about what we're going to talk about. We are designating all of the chapter 12 and the next 2 labs to the gas laws. Okay, so gases behave a lot differently than our solids and our liquids. Okay, and so we have to look at different conditions, different variables when we're dealing with gases. Okay, so one of those I have up here that we're going to go through all these laws here in a little while. But one of them is that gases exert pressure. Okay, so we have to take into account to the pressure that is being involved with the gas. We're going to look at constants that we use as well. They're called, or constants we'll have to look at. We also have to look at volume. And we have to look at numbers of moles. Okay, so we have different variables that we didn't have to look at with solids and liquids. So that's why this chapter is kind of totally separate. Really how I'm going to simplify it is that you really just need to know 2 equations, basically. You need to know the combined gas law and you need to know the ideal gas law. Okay, if you know those 2, then you can pretty much do any of the calculations. Most students, if they at least study this part and know those 2 equations, all from that point is you're given all the variables but one, and then you just plug them in and you do the algebra. So it's really not too terribly difficult to do that. For just a few minutes, we're going to look at chapter 12 just to get started here. Another reason why students usually do pretty well in this section, a lot of students have heard of Boyle's Law or Charles' Law, so it's maybe familiar to you. If not, it will be soon. So we're going to look at Boyle's Law, Charles' Law are the 2 main ones we're going to look at before the combined gas law. We won't get to those today. Okay, one of the biggest differences for gases versus your solids and liquids is the density. Okay, their densities are much, much, much less than your solids and liquids. So if you look at here, our solid or ice, it'd be 0.917. As liquid, 0.998, so almost 1. So we always say the density of water is 1. Okay, it almost is there. Okay, but then the density here is 0.000588. Okay, so what does that tell us about the molecules in a gas? Exactly. So that's pretty understood. But molecules are in random motion very far apart. Okay, so the density of gases is a lot less. This is just something that I feel like everyone should know, and surprisingly, a lot of people do not. But the composition of our atmosphere, what's it made up of? A lot of students would say, primarily oxygen. That's just what they think, okay? But it's actually 78% nitrogen, okay? 20.9% oxygen, then argon, then carbon dioxide. And we've got a few other gases here, methane, and then hydrogen is actually really low on these. So all this adds up to 100%. Okay. So there's a theory about gases. It's really just describing them. It's called the kinetic molecular theory. And basically what Emily just said, the gases are individual molecules that are very small and they're very far apart from each other. Okay, and they also move in continuous kind of random motion. However, they are kind of straight line motions. So gases move kind of in straight lines. They will collide, so we'll talk about putting pressure on gases. So we even kind of talked about that one day with respect to our soft drinks, okay, that we're kind of compressing the carbon dioxide into the soft drink. Okay, so talk about compressing and all that kind of stuff with Boyle's law and Charles' law. But basically, the net energy that we have with gases, so if they are colliding with the containers or wherever, these walls or wherever they are, the net energy is you always have a net energy where there's no gain or loss. Okay, so energy is conserved. Mass and energy are always conserved. You can't lose or destroy energy or mass. Between collisions, they have no force on each other. So they're so far apart that there's no hydrogen bonding forces necessarily. There's no dipole-dipole, all the forces that we talked about that keep maybe our solutions from last unit together or in solution. Okay, so they're moving so far apart, if they bump into each other, then they will randomly, but for the most part, they just move in straight lines and have no force on each other. Okay, so one of the biggest differences for gases is they exert pressure. So I mentioned that earlier. And we measure the atmospheric pressure with the barometer. So in lab this week, I'll see me, I have to climb up there and I'll read the barometer so we know the pressure of the room. It's going to be taken into account in our calculations for your lab today and for the next lab. I made little changes here. I don't know what happened with that PowerPoint. I don't know if I copied, pasted, or accidentally did something, but the definition of standard pressure, so we're going to see that a lot. We're going to talk about standard temperature and pressure. Standard pressure is 760 millimeters mercury, or 760 torr. Okay, so these two have the same conversion units here, or 1 atm atmosphere. Okay, 1 atm is 760, so you need to know these conversions. They're not, it's just a one-step conversion. You'll have to convert from atm to torr in certain situations, or the reverse. And 1 millimeter mercury is equal to 1 torr, so they have the same units there. Okay, so if an equation or a problem asks you for, if the volume changes or this happens at STP. Okay, STP is standard temperature and pressure. Okay, so it's often written as just STP. Okay, and this is a reference point for some gases. Most of our ideal gases, if we talk about their behavior, we're talking about them in respect to these conditions. Okay, standard pressure is 1 atm, we just said, or 760 torr millimeters mercury. Standard temperature is 273 or 273.15 kelvins. Okay, all of the gas laws that we're going to go over have to be in Kelvin. Okay, so you're going to have to convert from Celsius to Kelvin. Okay, so there's that. I know we talked about it a while ago. Okay, but you can use 273 or 273.15. Doesn't make much difference to me which one you want to use. Okay, we'll go ahead and stop here. We'll pick up with Boyle's law. Hey, be working on the redox and the titration calculations, and be sure you bring questions on Wednesday.